Hello, we're on 5.03 Algebra 2 today, and we're going to be talking more about solving log and exponential equations, but we're going to be using them in word problems and solving them that way. So I am going to attach a blank copy of this on to your Google Classroom, so if you'd like to print it, you can, so you don't have to write all of the word problems out. If you don't have a printer, you're welcome to do it on, if you have a Chromebook, you can do it right on there. Or if you don't have any of those options, of course, you can write it out and just kind of abbreviate where you need to. All right, so number one, Evabella invests $350 in a bank account that's compounded continuously. So really keywords right here, compounded continuously at a rate of 2%. How much would the investment be worth after 20 years? So as soon as we see compounded continuously, that's when you should be thinking about your formula of APERT. One of those formulas you need to memorize. All right, so A represents what we have at the end. P is your principal, so your initial amount. E is a number right from our calculator. R is the rate. T is the time. So she's investing $350. So that's our initial amount. We'll leave the letter E. Our rate is 2%. Now we can never just put the percentage in. We need to change it to a decimal. So right here, the decimal's after the 2. We move it to the left. To the left, that's how you change a percent to a decimal. So we have 0.02. And we want to know how much her investment will be worth after 20 years. So we're going to put 20 in for T. And we're solving for A. So this one, we have everything we need on this right-hand side. The only variable that we have is A, which is on the left. So I'm going to just go straight to my calculator and type in exactly what I see. So 350. Second ln is E with an exponent raised to the 0.02 times 20. And I'm going to type all of that in all at once, write out my entire decimal. So 522.13864442, and since it just says how much would it be worth, we're going to write the answer in just money, so in dollars, not to the nearest dollar, just in dollars, so about $522.14. Part B says algebraically determine the time it will take for the investment to reach $400, round to the nearest tenth of a year. So this one's a little bit different. She's still going to be investing her $350. E is not going to change. It's still compounded continuously, so it's still PERT. The rate is still 0.02, but this time we're looking for how long it's going to take. So I'm not giving you 20 years. I'm asking you how long will it take for her investment to reach $400. So this time the A will be your 400 because that's the amount we want in the end. Now, when we look at this equation, notice your variable is T, and that's in the exponent. And anytime your variable is in the exponent, that's when you should be thinking logs. I'm going to need logs to get my variable out of the exponent. Logs or ln's, natural logarithms. Before I can do any logs, though, or ln's, I need to isolate. So first of all, I see this exponent 0.02t. I want to know what's the base of that. So is it the E or is it the 350E is the question. So is 350 times E in parentheses? No, so this is only directly attached to the E. And that's really, really important. It's not, the 350 is not being raised to the 0.02t. So I want to isolate that E raised to the 0.02t. So I'm going to divide both sides by 350. When I do that, I get 8/7 equals E raised to the 0.02t. Now, since I have an E here, I'm going to use ln's as opposed to logs. So anytime you see an E, use ln. If there's no E, then use a log. So I'm going to literally just go to the front of each side. Of the left side, write ln, and the right side, write ln. So I take the ln of both sides. Now my exponent, once I have a log or ln, can swoop to the front. So here I have ln of 8/7 equals 0.02t times ln of E. Now if you forgot ln of E, so really that's saying E raised to what power gives you E. And e raised to the first power gives you e. So ln of e is just 1. So ln of e cancels each other out. So that gives us a 1. Now I want to solve for t, so I'm just going to divide both sides by 0.02. And then again, you're going to go straight to your calculator. So ln of 8/7. And then we're going to divide ln of 8/7 by 0.02. And you can do that in 2 steps too. And write out your entire decimal right from your calculator. And then round it, and it says to round to the nearest tenth of a year, so that would be 6.7 years. Again, you could have, once you isolated that e to the 0.02, you could have gone straight to writing it as a natural logarithm as well, if you're more comfortable with that. Either way is fine. All right, number 2, Jackson deposits $10,000 into a special bank account that earns 6.5% compounded quarterly. So notice this time we don't see compounded continuously, so we are not using APERT. We're using our other formula here, which is probably a little harder to memorize, which is 1 plus r/n raised to the nt. So that's when you really want to practice, rewrite it out a couple times, to make sure you have it down. And that you're going to use anytime you're compounding quarterly, monthly, anything besides continuously. How long will it take for him to double his investment? Round to the nearest tenth of a year. All right, so again, our principal amount is our initial amount that we invested. And I'm going to substitute that in. My rate, I can't just put in the percent, so I need to move to the left. So I have 0.065. Now, n represents the number of times you compound per year. Number of times that you compound per year. So, because it's 6.5% yearly. So we want, if we're compounding quarterly, then we're compounding 4 times a year. If you were compounding monthly, then your n would be 12. If you're compounding semi-annually, then your n would be 2. So I'm just going to put a 4 in everywhere I see an n. And I want to know how long it's going to take him. So that means I'm solving for t. And I want his investment to double. So he started with 10,000. So if that doubles, how much money would we want in his account? So you would just do 10,000 times 2, which gives you 20,000. So now we have everything subbed in. We have one variable, and that's t. So ask yourself, where is t? Where is your variable? Is it scenario 1, 2, or 3? So in this case, t is in the exponent. So we're going to need to use our logs. So anytime you see variable in the exponent, we're thinking logs. But before we can do our logs, we need to isolate. So what is the base? What's being raised to the 4t power? And this one is in parentheses. So it's whatever that is in the parentheses, that's going to be our base, which means we need to get rid of this 10,000. So it's being multiplied by those parentheses. So we're going to divide both sides by 10,000. And then all these zeros will cancel. We're left with 2. I'm also going to put this, what I have in the parentheses here, right into my calculator. So pause your video, type that into your calculator. And I got 1.01625 raised to the 4t. Whoops. All right, from here, I'd like you guys to pause the video and try to solve the rest of this completely on your own and then just check back. All right, so again, you would have put the log in front of each side. I'm going to go a little bit faster since you should have already done this on your own. So I swooped it to the front, and then I'd have log of 1.01625. And now it's just a matter of solving for t. So maybe I divide by log of 1.01625 first. and you're going to get a decimal there. And then I want to solve for t, so divide both sides by 4. Write out your entire decimal, and then round, it says, to the nearest tenth of a year, so 10.8 years. All right, and that's it for number 2. Number 3, a given substance has a half-life of 6,000 years. After t years, 1/5 of the original sample remains radioactive. And we're looking for t to the nearest 1,000 years, not thousand, thousand, ends in a D. All right, so first of all, I see half-life. So I'm going to write out my half-life formula. Another formula you need to memorize. So we've talked about compounded continuously is your A part. Then we talked about just compounded anything besides continuously is this formula. So that's 2 you need to memorize. And your third here is your half-life formula, which you take the initial amount again, times 1/2 is in the half-life formula, raised to, I always remember as the half-life, t over h, which does not stand for the, t stands for time. Time over half-life. Okay, so this one's a little bit trickier because they're not telling you how much you start with. They're just telling you that 1/5 of the original is going to remain. So you can kind of just make up an amount. So if 1/5 remains, I would maybe say if I start with 5 grams, then how many grams would be left if 1/5 of the sample remains? So 1 out of 5 of the original sample remains means I'd left with 1 gram. And then it's raised to, we're looking for t, and we know the half-life is 6,000 years. So now I have just one variable, so now I need to figure out how to solve this. So try to pause the video here, see if you can solve this on your own. So you should have looked at this and said, okay, the variable is in the exponent. I'm going to need to use logs. Before I can use logs, I need to isolate. So I need to get this by itself. So to do that, I'm going to divide by 1/5. So now I have 1/5 equals 1/2 raised to t over 6,000. My variable is still in that exponent, so I'm going to need to use logs to get it out. So I'm going to write log in front of each side. I'm not using ln because I don't see an e anywhere. Once I put the logs, now I can use my property to swoop it to the front. Here I don't have any exponents, so I don't need to swoop anything. So now I have t over 6,000 times the log of 1/2. I'm solving for t, so I need to get that. I'm going to try to get the t over 6,000 by itself. So I'm going to divide both sides by log of 1/2. Oops, that didn't cancel. And these canceled. I'm going to bring it up here. I'm just going to go to my calculator, type in log of 1/5, and an extra parenthesis there, divided by log of 1/2. And I'll write out my decimal. So now I have on the left side 2.321928095 equals t over 6,000. A couple ways you can think about this. You could multiply both sides by 6,000. You could put this one over 1, and now you have two fractions set equal to each other, so you can cross multiply. T times 1 is t. And then you can go right into your calculator. I already have this decimal, so just hit times, oops, too many zeros, 6,000. And write out your whole decimal, 13,931.56857. And then you're going to round that to the nearest 1,000 years. So here's your ones, tens, hundreds, thousands place right here. It's where you start talking thousands. So we go to the right of that. It's a 9, so I'm going to round up to 14,000 years, a very long time. 14,000 years. All right, moving on to something a little bit different here is some of our regression. So here we have a table that shows wind speed and the corresponding wind chill factor when the air temperature is 10 degrees Fahrenheit. So here we have listed all of our x, our wind speed, and here's all our wind chill. Letter A says write the logarithmic equation. So we're going to be using logarithmic regression. So that's ln reg, not to be confused with lin reg, which is linear regression, which is a straight line, where logarithmic is a curved line. So we want to write the ln reg, or the logarithmic equation, for this set of data, rounding all your coefficients to the nearest 10,000th. So whenever you do regression, it is extremely important that you write out all your steps. So we've done regression before. We did exponential regression. You guys have done linear regression in algebra. So we're going to write out the same steps you always write out. So stat, edit, in for L1, I'm going to put all my x values. In for L2, I'm going to put all my y values. And then I'm going to go to stat, calc. This time I'm going to find ln reg, which should be number 9 on your calculator. Then I want you to write out your A value, your B, and your equation. All right, I'm going to go over to my calculator now. So pause the video here. I stored mine already in there, so I'm going to hit stat, edit. Mine are already in there. Pause your video so that yours are in your calculator as well. After I do that, I'm going to quit that and then go to stat, over to calc, and then I'm going to scroll down to number 9, or you can just hit the number 9, and that's ln reg. So notice above it is lin reg. That's linear regression. This one is a logarithmic regression, so ln, natural logarithm. My x list is 1, L2 is my y list. The other two should be blank. I'm going to calculate. Remember too, I didn't ask you in this question about the correlation coefficient, but it is important to be able to find it. So whenever you do regression and before you start any test, I would go to second 0 and find your D section. So I go into the green D and scroll down to diagnostic on, which mine is already on. And then I'm going to push enter and then enter again. If that hadn't been on, then when I did this regression up here, I'm gonna hit enter again for that. I wouldn't have seen these R values. So now I'm just going to write out what I got for A and B. Again, I'm not asking for the R, but you could be asked for it. And that's called the correlation coefficient. So I write out my decimals. And then you'll see at the top of your calculator, it gives you the equation, y equals A plus B ln x. Y equals A plus B times ln of x. So you're just substituting in your A and your B values. And double check your letters too. It did say X and Y, but if they use different letters, you have to match up with those letters. And now I'm also going to take this time to round to the nearest 10,000th. So 10th, 100th, 1000th, 10,000. So I should have 4 decimal places. So 13.0134 for my A, minus 1, 2, 3, 4. So that one's going to round up. So minus, even though it's plus, I had a negative 7. So minus 7.3135 times your ln of x. So that is your logarithmic equation. So you're using regression. Remember, regression is just if I were to plot these points, you're finding an equation of a graph that would fit them best, fit them closely. And that's what that correlation coefficient tells us. If it's close to 1, that it's a good fit. All right, based on your equation, if the wind chill factor is 0, what is the wind speed? Let's go up to our table again to figure out which of those we're looking at. So wind speed is x and wind chill is y. So wind chill is y, so we're putting in a y is going to be 0, and I want to find the x. So I'm just going to use my new equation here that I just found, and I'm going to substitute in. So I'm going to put in a 0 in for y. And I want to solve for x. So here's my x, it's attached to the ln, so I can't separate those at this point, so I need to isolate them, which means I need to get rid of everything that's around it. So first, I need to get rid of this 13.0134. Keep in mind, you cannot combine the 13.0134 and the 7.3135 because the 7.3135 is attached to the ln of x. So you can't, they're not like terms. So this is negative 13.0134 equals negative 7.3135 times the ln of x. Now, again, I need to get that ln of x by itself. So I'm going to divide by negative 7.3135. And that I'm going to do right in my calculator. So pause the video, take a moment to type that in to find what the ln of x will equal. And you should have gotten positive now since negative divided by a negative. And here I need to now solve for x. So how do I separate the ln from the x? Well, this is actually part of your scenario 3. Given a log or ln, what do? Isolate, which we already did, and then rewrite it in exponential form. So remember, when you have an ln, your base is an e. So I could rewrite this as e raised to that answer I just got, and that will equal x. Remember, it's e raised to the number by itself equals the big number next to ln. So in your calculator, take a moment to do that. Oops. Let's see, I had negative 13.0134 divided by negative 7.3135. And now I'm going to do second E, and I can scroll up and grab it, or I can hit second negative, which is the last answer you had, and write out your full decimal, and then round it to the nearest miles per hour. So that would round to 6 miles per hour for your final answer. All right, this next one, number 4, I'd like you guys to try on your own. So read the question, write out the formula that you need to memorize, and then solve it, and you're going to round this one to the nearest 10th. Okay, pause that and go ahead and do that right now. All right, so this one should have been a little bit easier than the other one because it gave more specific data here. So here's your formula that you need to have memorized. Your original amount is 180 grams. We're solving for time, and that actual half-life is 7.2, and we want to know how long it'll take to be left with just 20 grams. So you should have isolated first, and I'm not going to go through this. This should be on your papers, but isolate that first by dividing by 180, then take the log of both sides. Then you can swoop to the front. The final answer, rounded, should be 22.8 days to the nearest 10th of a day. Okay, in your notes, you should have all of that work shown there. All right, number 5, Sabrin deposited $500 in an account that was compounded continuously. At what rate did she invest her money if it doubled after 10 years? Round to the nearest 100th of a percent. So a little bit different than the last one we did because I asked you to find the time instead of the rate, but same idea. So pause the video here, write out your formula, show your substitutions, and then solve for your rate and round it to the nearest 100th. All right, so your formula you should have used was your APERT, and that I would know to use that because it says compounded continuously. Sabrin started with $500. E stays the same. I don't know the rate, but I know I want to know how, if that her money doubled after 10 years. So doubling means I'm going to take 500 multiplied by 2. That gives me 1,000. So again, my variable's in the exponent, so I know I'm going to need logs or ln. Since I have an e here, you should be using ln. So you should have isolated your base with its exponent. So started by dividing by your 500. And then take the ln of both sides. Once you find r, and I'm going to write this one out because it's really, really important, but you guys should have, I'm not writing out all of the work. I'm just writing that answer out. You should have all the work shown how you got from, how you'll get this answer on your notes. And if you need help, make sure you let me know. So before you round, it's really important that you change it to a percent. So change it to a percent first, then round. If you round here, then we would just end up with 0.07. But we want it to the nearest hundredth of a percent. So first change it. So move your decimal over 2. And so now we have 6.9314718%. So rounded to the nearest hundredth would be 6.93%. So again, really, really important that you change to a percent before you round. All right, and the last one here, meteorologists can determine how long a storm lasts by using this function. D is the diameter of the storm in miles. T of D is the time in hours with respect to the diameter. The storm lasts 4.75 hours. Find its diameter. So we're looking for D to the nearest tenth of a mile. So T of D, the most common mistake here is that students think of T of D as T times D. But it is just like saying like f of x. It's just how we write the function out. So T of D is one thing. It's really your time. So almost think about it as just T equals 0.07 D raised to the 3/2. Pause the video, see if you can solve this one on your own. It's a little bit different. You're actually not going to need to use logs for this one. All right, so we know the storm lasts 4.75 hours. So that's your T. So that's what we're going to set it equal to. Now here, my variable is not in the exponent like it was before. So we're not using logs or ln's to solve this. Our variable is actually in the base. So this is scenario 2. So we still need to isolate, and get that D raised to the 3/2 by itself. So to do that, you're going to divide both sides by your 0.07. Now I have 67.85714,286 equals, those cancel, D to the 3/2. Now in scenario 2, and if you need to, pause your video, go back and look at your 5.02 notes to see what do we do when the variable is in the base. So you should have either remembered or looked up that when your variable's in the base, we want to get it to become D to the first power. So what we can do is raise it to the reciprocal, because when we raise a power to a power, we powerply them, which means they multiply. And 3/2 times its reciprocal of 2/3 gives you 1. So that's going to give me D. If I do that to the right-hand side, I also need to do it to the left-hand side. So here, you're just typing that whole thing right into your calculator. So you would already have 4.75 divided by 0.07. And now you're doing that raised to the 2/3 power. Write out your whole decimal and round it to the nearest tenth. So you should have that whole thing written out yourself and then round to the nearest tenth, which is 16.6 miles. All right, and that is it for our word problems today. You guys will be having a test the next time you are in class on units 4 and 5, so on all exponentials and logarithms. So really take time and make sure you can do all the problems on the homework independently, which is review, and let me know if you have any questions at all. And I hope to see you guys soon. Bye out.